Or if you know that 3 times 3 is 9 times 3 again is 27, you know that the cubed root of 27 is 3. So to simplify it all the way, the cubed root of 27 is 3. So that comes out of the radical sign, and we'll keep x to the second power under the radical sign. It's the cubed root of x to the second power. So that would be your final answer, all the way simplified. Now if you look over here at number 9, that's the fourth root of 81 x to the third. It's written in radical form. We're going to do the opposite of what we just did in problem 1, and we're going to start in radical form and write it in exponent form. Now remember, this is not in parentheses. The 81 and x are not in parentheses, so the third power is only with the x. The 81 has an understood first power with it. If you want to write it in there to help you remember, you can. So I'm going to take 81 out of the radical sign and write it with a rational exponent, with 1 being the power, 4 being the root. So 81 to the 1/4 power. And then x also is going to be written with a rational exponent, but x has a power of 3 and a root of 4. So x is going to be to the 3/4 power. So that's taking out of the radical sign and writing it with a rational exponent. And just like with number 1, 81 does have a perfect fourth root to it. If you can either take the fourth root of 81 in your calculator or put 81 and raise it to the 1/4 power, you're going to find the answer is 3. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So the fourth root of 81 is 3, and then we have x to the fourth power in the final simplified form. Number 10 is a volume problem. Volume, we've given you the formula, length times width times height. So if you have a three-dimensional object, you're going to multiply together the length, the width, and the height. It does not matter which is which because multiplication is commutative. It can be done in any order. So we're going to multiply together a squared b times ab squared times ab to the third power. Okay, remember, when you multiply the same base, we're going to add exponents. If a variable or a number does not have an exponent, we always assume it's to the first power because there's one of those. So a has a first power and a has a first power. Multiply the same base. I'm going to multiply a to the second, which is the same thing as a times a again, times a again. An exponent tells you how many times you're multiplying something times itself. So I'm multiplying a twice, once, and once. We're going to add 2 plus 1, which is 3, plus 1 again, which is 4, giving us a total of a to the fourth power. We're going to multiply a times itself a total of 4 times. The b's we're going to do the same thing with. B, we're multiplying 1 time here, 2 times here, and 3 times here. So we're going to add 1 plus 2 is 3, plus 3 again is 6. So a to the fourth, b to the sixth power is what we get when we multiply the length, the width, and the height of that object. Okay. Over here, it asks us to write it in radical form. So again, there's 3 examples, kind of like the one we've done up in number 1. They have rational exponents. We're going to write it in radical form. So right here, I'm going to take 9 as my base, and I'm going to put 9 underneath the radical sign. The numerator becomes the power. The denominator is the root. So we're going to leave 9 to the fourth to the fifth power. Okay, that's not going to have, we're going to just leave it like that. On B, I want you to really pay attention to the fact that that is not in parentheses. So 36 has an understood 1 with it. There is no such thing as a root of 1. The smallest root we have is the square root, which is the 2. So 36 is not going to go under the radical sign, but y has a rational exponent. So y is going to go into the radical sign. So here we have 36, and under my radical sign, I'm going to place the y with a power of 1 and a root of 3. You do not need to write the power of 1, because it's understood that it's there, but we do need to write the root 3. Anything over a 2, you need to write what the root is. And that's our final answer. There's nothing more that we can do. The difference between C and B is that C, the 36y, is all in parentheses, so all of it has a 1/2 power with it. So when I put this under the radical sign, the 36y is all going under the radical sign. And they both have a power of 1. Put it in parentheses or not, they both have a power of 1, and they have a root of 2. You may put a root of 2 into the radical sign if you'd like to, but anytime you have a radical sign with no number over here, it always refers to it being a square root over 2. Now, there is a perfect square root of 36. 6 times 6 is 36, so the square root of 36 is 6. So to completely simplify it, I will take the square root of 36, which is 6, out of the radical sign, and y is going to stay under the radical sign because there's not a perfect square of y itself. So that's how we're going to turn those into radical form. Make sure that we can see this on here. All right, same thing here. We're going to go backwards. We're starting in radical form. We're going to go to fractional exponent form. Again, 25 and b are both under the square root sign. Okay, we could kind of start at two different places here. If you know the square root of 25 is 5 off the top of your head, you can go ahead and just write that as 5. I'm going to write it in the rational exponent form first, just for practice with that. But remember, 25 is understood exponent of 1, and so does b. And if there's no number in this radical sign, I'm going to go ahead and put a 2 there. It's understood to be a 2 at the square root. So if I write it with a rational exponent, I'm going to write 25, and it has a power of 1 and a root of 2, so to the 1/2 power, and b is the same thing. B is going to have a power of 1 and a root of 2. But like I said before, 25 does have a perfect square root. And if you put in your calculator 25 to the 1/2 power, it's going to tell you it's 5. Remember, after several patterns, we see the same thing. Anytime you have something to a 1/2 power, it's the same thing as a square root. It's just written in a different form. So 25 to the 1/2 power is 5, and we have b to the 1/2 power. Okay, then we're going to look at b. Okay, 3x squared, the whole thing is squared. So that second power goes with the 3 and the x. And again, on the outside, there's no number, so we assume it's a square root. So if I have 3x, the whole thing, and I'm going to bring power over root to 2 over 2, well, if you can simplify a fractional exponent, go ahead and do that. Since 2 divided by 2 is just 1, this is the same thing as 3x to the first power, which is just 3x. Okay, so simplify the fraction and the exponent also if you can. And then down here at c, is 64x cubed, but it's the third root this time. So we know what times itself 3 times gives us 64. Okay, again, that's not in parentheses. The 64 has an understood power of 1. So here we have 64 power over root to the 1/3 power, and x has a different power than 64. X has a power of 2, so x is going to be to the 2/3 power. Okay, now again, I want to check this number out, and I want to make sure it can't simplify any further. So I can either put in the calculator 64, and then your second button, and use the root of 3, or you can write 64 and use your power key on your calculator, that y to the x power, and put in 1/3 for the exponent. You're going to find out that's 4, because 4 times 4 is 16, times 4 again is 64. So 64 to the 1/3 power is going to be 4, and x is going to have the 2/3 power when we simplify it there. All right, the area of a rectangle is 44x cubed y to the 10th, with the height equaling 11x y to the 4th power. Determine the length of the base. Now, we've been doing a lot of area where we give you the height and the width and ask you for the area. This was a little different. They give you the area. So remember that if area equals length times width of a rectangle, or they're using an h there, so they're talking about base times height. It's the same thing, just different wording. So I'll go ahead and put a base times height since they used an h there. This time we know the area, we don't know the base. So we're going to work backwards. We're going to start with the area, and if I want to know what this base was, I could divide by the height. It crosses out there, and so area divided by the height is going to give us the base. So we'll start with the whole area. This 44, x to the 3rd power, y to the 10th power. I'm going to divide that by the height, by 11x y to the 4th power, and what's remaining is going to give me the base. So remember, 44 and 11 are just coefficients. They have no exponents with them, so we're just going to treat those like we would any other number. So 44 divided by 11 is 4. And then we have our exponents. There's 3 x's on top. That's the same as x times x times x, and only 1 on the bottom. If you're dividing the same base, we're going to subtract exponents. It's understood 1 here. Now there's 3 x's on top and only 1 on the bottom. So the x is going to remain in the numerator. It's going to remain up here at top because there's more up there. So 3 minus 1 leaves me with x to the 2nd power in the numerator. And then the y's, we have 10 on the numerator and only 4 in the denominator. So again, we're dividing the same base, so we're going to subtract. 10 minus 4 leaves me with y to the 6th power in the numerator. And that's going to be what the base of the rectangle is. If you want to check your answer, you can multiply this times the height, and you should get 44x cubed y to the 10th for your area. That'll check your answer for you. The other thing we're going to be finding the area of is a triangle. A triangle is the same thing, but remember, any triangle is half of a rectangle. If I kind of drew in the rest here, you can see that could make one whole rectangle. And since the rectangle's area is base times height, and a triangle is 1/2 of that, we're going to take half times base times height. So I'm going to multiply these two numbers together. 4x y to the 10th power times 7x to the 4th power y to the 9th power. And once I multiply those, I'm going to multiply the whole thing times half. Okay, now notice that 1/2 is not an exponent, so it's not going to apply to the exponents. 1/2 is just going to be multiplied times the coefficients. So we're going to 1/2 times 4, which is 2, times 7, which is 14. So it's going to be 14 for my coefficient, And now I'm multiplying, so I'm multiplying the same base. X is understood 1, there's 1x here, and there's 4 there. So if I add together how many total times I'm multiplying x, 1 plus 4 means x is going to multiply times itself 5 times. And then for the y's, same base, so we're going to add the exponents. And 10 plus 9 means y is going to be to the 19th power. And that's how I find the area of the triangle. Just take the same thing as the rectangle, but we're going to take half of the coefficient, because 1/2 base times height. Okay, let's turn that over on the other side. And right here, I've got